Hello friends, in this video you will learn how to use 3 extensions of the Postgres ecosystem to perform the vector similarity search within the database from start to finish. Obviously we will begin with the pgvector extension that lets us store vectors in the database and perform various operations on those. Then I will introduce you to the pgvectorize extension. With that extension we will be able to take user prompts and generate embeddings from within the database, not leaving the boundaries of Postgres. And lastly, I will show you how to take advantage of the PgCompute extension. With that extension, you will be able to create, develop your functions within your application logic, and then the PgCompute will take that logic and execute it on the database automatically for you. Sounds like a good plan? Let's not waste a minute and do a deep dive. Alright, first let me introduce you to our sample application that we are going to optimize today. And if that's not the first video on my channel that you're watching, you've seen this application before. This is a lodging recommendation service. If you're traveling to San Francisco, you would like to get some recommendations, you just need to type in your prompt and the application will come up with various recommendations. For instance, I'm traveling to San Francisco and I want to stay near the Golden Gate Bridge. Clicking the search button and getting a few recommendations. I like those. The question, where those recommendations are coming from? Let's jump to the source code. So this is the application logic that is responsible for the retrieval of those recommendations. In the beginning, you can see that we are configuring a database endpoint. And as you guess, the database is Postgres, an obvious choice for me. After that, there is the connect method. It will open a connection to the OpenAI APIs, and also it will establish a connection to Postgres by using this client. This is the driver for Node.js. Next, this is the search places method. This method gets executed whenever you click that search button on the application interface. What's happening here? This function will take your user prompt and make a call to the OpenAI embedding APIs to generate an embedding. And presently we use the following embedding model. Once this embedding is generated, it will be passed as a parameter along with a few other parameters to the following SQL statement. And this SQL statement is going to be executed on Postgres. If you take a look at it, you will see that this statement performs the vector similarity search over the data that is stored in your database. So generally speaking, this method will try to get the most relevant login recommendations based on your user prompt. Once we are getting this result back from the database, we will reconstruct a JSON object of the following format, and this JSON object is going to be displayed for you here. This is the result. This is how it works. Now, we are using the pgvector extension to perform this vector similarity search. And pretty much you can deploy any flavor of Postgres and just make sure that the pgvector is enabled and installed there. Today I'm using Tembo, and Tembo is a cloud native Postgres. The superpower of Tembo is the extensions. If you go to the extensions repository, you will see that Tembo out of the box supports over 200 PostgreSQL extensions. And for my video, I needed 3 extensions to experiment with. What I have installed, I have several extensions installed, and one of those extensions is pgvector. It's here. And next we are going to take a look at pgvectorized. With this pgvectorized, we will be able to generate an embedding for our user prompt within the Postgres database. Let's take a look how we can accomplish this, jumping back to my source code. Let's scroll up a little bit. What we need to do is to update the SQL statement if you would like to use the pgvectorize. And my friend, it's very easy to accomplish. What I'm going to do, first I will create the following common table expression. The name is going to be prompt. I will make a call to the pgvectorize. You need to use the vectorize and then call the transform embeddings method. This method accepts several parameters. At least you need to provide the input, and that input is going to be passed as a parameter here. Once this embedding is created, we want to transform it to the vector type. Lastly, I want to store this value as an embedding column of my common table expression. So looks good. What's next? we need to update this part. As long as this embedding is now generated from within the following common table expression, select embedding from prompt, and we also want to order by the same distance. Finally, what we can do, we can optimize our application logic. We no longer need to generate this embedding using the OpenAI APIs directly. Instead, what's going to happen is when you're executing the pgvectorized transform embedding method, and if you're not specifying any other LLM provider, then vectorize is going to use the OpenAI model. So we are good here. Then we also can easily pass our user prompt as a parameter to the SQL statement. So let's recap really quick. The search places method is called whenever you click that search method button on the UI. And then we will execute the following query on the database. That query will use the pgvectorize extension to generate an embedding for your user prompt. And the user prompt is passed as the first parameter. It's here. And then we are using that generated embedding to calculate the distance between other Airbnb lodging options that are stored in the database. Cool. So this is the first optimization. Let's restart our application and see whether it works or not. Starting. Jumping back to our application UI. Let's do the search. Yeah, it looks like everything works. This is what we are getting from the database. Just to make sure, let's say that I want to find some cool apartment in the Mission District. The search happened successfully in Postgres. Now, we've already did this, but how about PgCompute? Let's see how PgCompute can help us further by taking this whole logic and executing it entirely within the database. Before, I want to do a quick tour to PgCompute. This is the repository. One thing is that pgvector, pgvectorize, and many other extensions that are available on Temba, they are server-side extensions, meaning that they need to be installed and enabled for Postgres. But PgCompute is a client-side extension. This is basically what you are using from within your application logic, from within your development environment. It will let you to create, optimize, and maintain database functions similarly to the rest of the application logic. As an example, let's say that you have this JavaScript function in your application and you just want to get this function and execute it on Postgres. It's easy to accomplish. All you need to do is to have a connection to Postgres and then create an instance of PgCompute and then execute a method like this that will take this function, the sum, deploy it to Postgres and execute it for you. Sounds cool, right? Now, let's do the same for our search places function. First, I will create the following function called search places within Postgres. And it's going to accept a few parameters here: prompt, the user prompt, threshold, and the number of records we'd like to get. How about the implementation? We're definitely going to change the implementation of the search places method that is executed by the application UI. And I will copy and paste the current implementation into the search places within Postgres. Yes, this one will remain, but here is once PgCompute will send this function for the execution to the database, we will not be able to use the following APIs of JavaScript. Instead, we need to use the PLV8 extension of Postgres, which has their execute method. And PLV8 is an official and trusted extension that lets you execute JavaScript logic within the database. I have this extension installed. Here is my Temba instance and PLV8 is here. It's enabled. Now we have this PLV8 execute method and we are not changing anything in the SQL. Everything remains the same, only the prompt. Yeah, let's do this. Finally, we also don't need this conversion. What I know, when you execute PLV8 execute method, then it will return those places. And the result is going to be converted to the JSON format. So now this is our implementation. Next, we need to execute this function somehow on our database. That's the time for PgCompute. Let's stop our instance right now, and we need to use npm install pgcompute method to add the extension to our Node.js project. Cool. Ready. Let's add the PgCompute object to our project. Yeah, looks like this. And in our connect method that opens a connection to the database, we also want to initialize the PgCompute. PgCompute needs a connection to the database. This PgCompute, it has this PgCompute init method where you need to pass the client, and we need to wait for it to be initialized. Okay, it's ready. We've got the object. What I need to do next? I need to take my instance of PgCompute and execute the run method. Into the run method, I need to pass the name of this function, switch places within Postgres, and my parameters. What we have prompt, we have threshold, and we have the matching count. Wonderful. That's it. That's our implementation. Okay, one last look, PgCompute run. I forgot one thing. I need to pass the database connection. One more time. The database connection is here, and the method that we are going to execute and the parameters. Let's restart the application logic. Everything is up and running. Now, fingers crossed, my friends. Okay, we've got some exception. Let's check the logs. This error is coming from PLV8, so generally this function was successfully sent to the database, but then I think we messed up with parameters. Let me check the logic, switch places. Yeah, the names are different. I need to change the names. Probably I should have kept the original ones, but that was an easy fix. Restarting the application. One more search. Okay, now looks like everything is good. How about we do this one more time? I want to stay near the Salesforce Tower and coffee shops. Search. Cool, everything is working right now. To recap, now when you execute the search places button, we will execute this search places method. That search places method will use the PgCompute extension of Postgres to take the following logic that is part of your application and execute it on the database. And within this logic, what do we use? We use pgvectorize to transform this user prompt to an embedding. And then we use the pgvector extension to find the most relevant places to stay for your user prompt. And when you execute this logic on the database, we are using the PLV8 extension of Postgres. Job done, my friends. How do you like it, my friend? Isn't it cool? Within a few minutes, you learned how to use 3 extensions of the PostgreSQL ecosystem to perform the vector similarity search from start to finish within the database. And this is just the beginning. If you take a look at the ecosystem of Postgres, you will find many more valuable tools that will simplify the creation and maintenance and development of your applications. Have fun building generative AI applications with Postgres and stay tuned for new videos. Bye bye now.